Thank you for coming. Hope you had a good lunch. They say after you eat, you actually have some going down with the cognitive abilities, but we're going to talk about JavaScript, so it's fine. I don't know why you're laughing. Okay, so this is going to be a big picture, really fast talk, and the intended audience here is twofold, and the purpose is twofold. And I'm actually going to ask you, if you don't mind, raise your hand if you do front-end development mostly, like if you do work with JavaScript. Okay, perfect. That's about half of you, I'd say. So this is the one audience. I want to show JavaScript developers and front-end developers what else is there, and basically ways to avoid JavaScript. The other part of the audience is someone, maybe functional programming or back-end programming, who is interested in front-end, but maybe scared. So are there back-end or FP programmers? Okay, the other half. Perfect. Yes, perfect calculation. So that was the who we are all different. This guy is a back-end programmer. So my name is Rakhim. I've been doing software development, mostly web, and I've been teaching programming in a college setting and then online doing my own educational startup. And I quit it. It's Headset.io. It's still pretty much alive and going on. And I'm working on something else now and hopefully launch in a few months at codeexpands.com. This is my Twitter if you want to shout and do stuff, and that's a website. All right. So the agenda, we'll start with the agenda. Maybe talk about recursion, JavaScript, Clojure, and then most focus on ClojureScript. And I've been doing a short version of this talk back at, in Helsinki at meetups, and there were a few questions afterwards, and this is why this is so big. There's so much stuff. I'm trying to show the big picture as much as possible. Okay, so React, half of you are for sure familiar with React. It's a declarative library for JavaScript, and its intention is to do UI. And UI is hard, and this is one of the problems that React is trying to solve. And there are actually two distinct problems that explain why something like React exists. And half of it is intrinsic. UI is hard, regardless of the platform. It's something that functional programming folks actually don't like, because it's actually like a functioning programming nightmare. Because UI is about two things. It's about mutable state, which we don't like, and it's about side causes and side effects. So it's like the worst parts of programming, and frontend is all about that. So it's all about UI, and I'm not even talking about browser stuff. Now the second part is not intrinsic, so it's not the problem that is unavoidable, but it is unavoidable at the moment because we have the browser, we have DOM. DOM is hard, and it's not really intended to be a platform for what we use it for: web apps, complex UI, etc., and so much state in this. So if you think about it, HTML and the DOM model are really bad things for UI and for this problem. And if you just look at the history and just explain this to someone who just coming into the industry. So there were a bunch of scientists and they wanted to share documents between them. So they took the analogy from the newspaper layouting and magazine layouting, and now we use it for everything. This is just a coincidence of history, and we're moving slowly away. Probably at some point we're gonna lose this thing, but for now this is sort of like this. Like, I invented a book. Look, this is a book. It has pages and information, and everybody is, yeah, awesome. Let's like build houses out of books. Why not? So one of the problems that React is trying to solve is that DOM is slow, and if you want to update something in things like jQuery or just direct vanilla JavaScript, you want to inject some information into some DOM element. You first have to find it. So it's a huge tree, and then you have to update it. And this works okay if something like in jQuery you just want to change the color or something. But now you have the state in the UI, and it's a bad place for the state. And most of the problems that frameworks like Angular or Ember trying to solve is that we have state which is real somewhere in your model, then you have state which is real for the user in the UI. And all the bugs, all the problems, most of them are because they sometimes mismatch. Because of this browser environment, because of the complexity of data itself, because of unexpected stuff, side causes, things like different connections. Now, this web thing should have been like the equalizer. Like, it's awesome, we now have this universal browser, we don't care about the machines and CPUs and memory more or less, and we're supposed to have this universal platform. But it's far from universal in reality, because my internet is not your internet, even though supposedly it is, but different countries, you just go, to China or Russia, and suddenly half of your CDNs don't work. You have to account for that. The browser, yes, it's like a single thing, and maybe it would be better if we only had one browsing engine, which we might have thanks to Google at some point. But for now, we still do have different browser engines, and we have websites that help us to determine, will this feature work in this version of that browser? And it's crazy. And so the web is difficult, and this fragmentation is so bad. This is why many mobile developers, like iOS developers, they are scared of Android because there are so many different devices. And Android and iOS developers are scared of web because now we have practically infinite number of devices. So one of the ideas, and this was in the keynote talk today, is that, hey, what if we just don't care about state in the view and we just re-render the view completely every time we change data? Now, this is expensive because of DOM, because if you need to update 50 different elements, you have to find them, you have to inject them, and the browser is janky when you do that. And we saw that if we find a way to do this effectively and quickly, then we can just see the view as this side effect, this basically accidental side effect of your actual program. You kind of don't really care what is it. It just re-renders, it always reflects the current state. So you take the notion of time out of it, and you take the notion of state out of the view. And the problem there is it's slow if you want to re-render your whole page every time. This is why something like React exists, and React is that kind of a library, so they call it a framework sometimes, but I would say it's a library that you can do in like one day yourself. And the idea is you have a virtual representation of your DOM, of this view tree, and then if something happens, if some change occurs, you do the change in your virtual DOM. You don't touch the real stuff, which is expensive. You do your virtual DOM, which is non-expensive because it's your data in memory. You model it as you wish. Then you calculate the difference between the real stuff and your virtual stuff, and you only inject that difference inside. And it happens that in the browser, this is quite fast for most purposes. Like, user clicks a button, something changes. It's not that much. Even if 10,000 things change, it's still surprisingly fast. So React does a lot of calculations of how to do this effectively, but then it just happens. So yeah, I was looking at this and then that. So this is like, if you go to the front page of React website, they say that's hello world, basically. I only added one thing. And you can see there's a lot of things here that people coming from most functional programming languages could not like. We see a class already, which already has some inheritance. We have a function, okay. We have two imports, and then that's how you inject that element onto your web page. Now, this is not the only way to do React, but this is still the main way. You do classes. And there are some problems with this. So you might not care about classes. You can avoid this. There's a new feature coming into React called hooks. You can do stateless components like that with just functions. And when they presented this is kind of funny, in the JavaScript world, there are new features coming out, but they're basically things from the 60s or obvious things like, hey, what if we don't do classes? Mind blown. But you can do just a function that renders data. So that's one problem. But you have an alternative. Another problem is that they decided to inject HTML for the virtual DOM inside the language. So if you just do JavaScript and you've never seen React and JSX, this is weird because now this function returns what appears to be HTML. And HTML, well, it's supposed to be a string, right? But no, it's now not a string. It's this new thing. So JSX is built on top of JavaScript. It's a superset of JavaScript, and you do HTML, but it's not real HTML because, first of all, it's for the virtual DOM, and second of all, you're still in JavaScript. So if you want to say that my HTML element has a class, you cannot say you have a class because class is a restricted word in JavaScript, and you actually use it there, class hello world. So you do class name because well, we have to do class. And then in JavaScript, you do camel case. So something like something in HTML that is dashed, we do camel case. So it's almost HTML, but not quite. And this is the promise of React. This is something that if you just look at the theory, you look at it and you think, wow, this is amazing. View is so easy. It's just a function of data, right? And you get into the world of JavaScript, and it's that. You still have that core idea, but now you have multiple layers of abstractions over it. You have lots of tools. When you say data, you actually have different kinds of data. When you say you have a component, you actually have at least two kinds of components. And you have inheritance with classes, which you can avoid, but you still, like if you go into the real code base, you still have that. You have other completely separate libraries and many alternatives to those libraries to deal with all that data and state. And you have confusing stuff, which is, you have ES6, which is the new JavaScript, but it's actually ES 2015, not 16. And you have ES 2016, and it's not ES6. And you have node libraries, and you have the NPM package management. Oh, so this is the reality. And JavaScript is a weird language. So this is a table that shows you what data coercion JavaScript does. And it turns out you just have to remember, an empty array is the same as false and the same as 0. This is why they have another operator, which is, I call it really equal. Like this is properly equal. And the general consensus is, you have this operator, don't use it. Use that. It's going to be sane. And there's actually a game on the web called Minesweeper. But you have to guess all those things. So of course, people don't like it. They want to avoid this, and they do. Okay, so maybe there are other languages that we can write stuff in and then compile into JavaScript. Just see JavaScript as this target language, basically assembler for the web. And some of the ways are TypeScript, which adds optional static typing, or Elm, which is heavily influenced by ML family of languages and Haskell as well. It does immutable data and, of course, static typing as well. And Reason, static typing, PureScript, Haskell for the web. And you see there's a common thing here, static types. And I'm not sure if there are other Clojure talks at this conference. I feel this is the only dynamically typed talk. So people tend to approach this problem of JavaScript. One of the main problems of JavaScript is it's going to be fine if we add static types. But talking to people, I find that many people confuse two orthogonal things. When they talk about JavaScript, they compare it to other languages, and they talk about that weird coercion and automatic type detection. And they're actually talking not about static versus dynamic typing. They're actually talking about weak versus strong typing, right? So those are different things. You have languages like JavaScript, which are on the dynamic side and really weak. So if you do empty array plus empty string plus 7, JavaScript will not complain. It will just assume this means something. And it's probably not something that you meant, it's probably not something you should do, but it will do it because it's weakly typed. But something like Python wouldn't do it, or something like Clojure, you would say, that doesn't make sense because they are strongly typed, but still dynamically typed. So I find it useful to think of these ways, of these gradations as dynamic versus static is when to check types, like before running or at runtime, and strong and weak is how serious are you. So you basically you relaxed about types or like really strict about, like scientific about types. So Clojure is another way to avoid JavaScript, namely ClojureScript, which is Clojure to JavaScript compiler. And it's dynamically typed, it's a compiled language, it's a dialect of Lisp, so you have parens. It was created as a hosted language, meaning it's meant to run on some host machine. It's meant for JVM in the beginning. Now it compiles to JavaScript in this example. And it's homo-iconic as Lisp should be. So data is code, and you can manipulate code within the language. This is why many features of Clojure are shipped as libraries. So, for example, they've added a synchronous communication as a library. They didn't rewrite the compiler to add async into the language. And it's data-driven. You have built-in data types, and you tend to use them most of the time. You don't need classes, you don't need anything like that. And they are really fast, they are really good, they are immutable. So the core philosophy of Clojure and ClojureScript is this: use data. Data is simple. Data is the truth, the end truth. Work with that. Don't add complexities on top of data. Use small composable libraries. So sometimes people come in and they ask, what is the Rails of Clojure? And there is none, because if you want Rails of Clojure, you have all the pieces as small libraries. You just combine them as you wish. They will probably work. And the world of Clojure is more stable in this sense that if you go on GitHub and you look at the library and it's a JavaScript library and the last commit was 3 years ago, you would think this is abandonware. Like, the guy is probably dead. This will probably not even compile because there are 2 more versions of Babel and Webpack after that. If you go to a Clojure library like that and it's 3 years ago, that's fine. It means it's probably working as intended. You don't need to add features all the time. And if you look at commit history of Clojure, it's like 15 commits before new release per year, and just, And in this sense, and in a sense of combining small things and being universal, I compared this language like Lego blocks, which if you combine multiple Lego blocks, you create some thing out of Lego blocks. An interesting thing about that is there's still a Lego block. It still has the same connectors everywhere. So no matter how complex your thing is, it's still carrying the same interface. But some toys are not like that. Like this kitchen set, I actually Googled sexist Chinese toys. So there's the woman cooking and the woman cleaning. It's horrible, but that's an example of this could only be for playing kitchen. This could only be for playing whatever that's supposed to be, and Lego is for everything. And with this, super hyped JavaScript world, I moved to Finland a few years ago, and moving from a North American country to a country like Finland, it actually feels sort of like moving from JavaScript world into the Clojure world, because JavaScript is like that. It's this new thing. We have news, we have updates, update. And then Finland is like, relax, just go in the sunset. So another thing about Clojure, which is good, is simple infrastructure. In JavaScript, you have different tools for different things, and you actually have competing tools, and maybe it's good, but to just run, React Hello World properly, you need a transpiler, you need Webpack, you need NPM, you need maybe 50 dependencies, and it's multiple tools, and there are templates, of course. It's not that hard to copy, but the complexity is there. With Clojure, you basically need one tool. It's called Leiningen. You see, there is an alternative. There are other things, but if you stick to that one tool, that's it. You don't need anything else. So before we get in ClojureScript, one last thing about Clojure itself is how it manages state. So that's an example from Java concurrency book, and it's just a class with one value in it and a function that returns the incremented value. So the problem with this code, as explained in this book, is that if that code is run in different threads simultaneously, you cannot guarantee that this is safe, because if you want to increment the value, it's not an atomic operation. You have to read it, you have to change the value, and then you have to write it down. So you have three things, and now you have race condition if multiple threads are doing it, right? You can read, and then someone else does it and does it faster, then you write it down and it's wrong. So in Clojure, they of course see this problem and they wanted to solve it. And there are different features, but I'm going to talk about atoms because that's the main feature that's also present in ClojureScript. Just as it is in Clojure, you can just copy and paste code from your backend into frontend and vice versa for the most part. And it's just a safe, basically a safe variable. So if you have an atom with an integer and you have a function that applies an increment function to that number and you run it in multiple threads, the end result will be guaranteed how many times you call it. Now the thing is, there is still race condition, right? You still have to increment, and increment is still this multiple non-atomic operation. But the atoms in Clojure are done in a way that if you start doing it and race condition happens and this value changes, then it will kind of step back and try again. So it might try this code multiple times until it actually does it in an atomic way. So I'm going to show you a demo later how this works in ClojureScript, and it's just like a free, transparent way to do safe synchronous shared state. So ClojureScript is closer to JavaScript compiler. For the most part, you feel like you write Clojure. It's in terms of features, it's a subset of Clojure. So if you know Clojure, you don't need to learn anything new about ClojureScript. It takes advantage of Google Clojure with S. It's a compiler that compiles JavaScript into super fast, efficient JavaScript, and Google uses that compiler for all their maps and Gmails and stuff. And the bad thing about Google Clojure is that to take advantage of it, you need to write some specific ugly JavaScript. The best part is that if you write ClojureScript, you don't write JavaScript, right? And it transpiles it into this weird, ugly JavaScript. You don't see it, you don't care. Then it goes into Google Clojure and becomes super fast. So you can still share code between backend and frontend. The library is itself actually smaller than jQuery, so it's not like this huge thing on top of JavaScript. And for certain things, it's actually faster than native React. Not React Native, I mean just React for the web. And that's thanks to immutable data structures. So this is the tools I'm going to cover. Super basic stuff if you want to get into React using ClojureScript. So you have the language, then you have this ClojureScript to JavaScript compiler. Then you have React on the JavaScript side, and there is a library called Reagent. This is probably the thinnest, the simplest wrapper on top of React. So that's a way to do React from Clojure, but still think in terms of Clojure, still think in terms of Lisp. And then there's a tool called Figwheel, which hot loads your code into the browser. You just save your code, it hot loads. The best part is that it's not restart, it's not refresh your page. It actually hot loads and injects the changes. So if you have an app and you run it in the browser, you navigate, you do something with it, you add stuff, you type in, you change the state. And then you go back into your code and maybe change DOM or change styles or change the function. The browser refreshes, but you stay in the same state. You don't have to get back into that state, even if the DOM changed by your changes in code. It's magic, it's amazing. And this cool tool, Leiningen, does everything for you. It runs, it does dependencies, etc. So it works like that. You have the line command, and you can create new apps with it, and you can provide a template name. Now, people create templates for Figwheel, for Reagent, for whatever libraries. If you don't say template, you are creating a Clojure library, and if you say app, you create a Clojure app. So we're going to say Figwheel, which is the template for this app, and it also now we also add Reagent, which is the React wrapper. And after you do that, that's all you have. This is your whole thing, and this is where your code lives. This is where your HTML, where that thing injects into, and that's it. So this super slim template doesn't include testing yet. If you look inside the project, this project CLG, it's for the JavaScript people, it's package.json. It's the way to describe your package, describe your dependencies, etc. The cool part here is that dependencies include Clojure and ClojureScript. So the language and the language on top of that are dependencies of your project. So the whole set of problems of setting your environment and having different versions of the language, you don't have that problem. It's just your dependency. I also have async here and reagent for React. And that hello world thing, it looks like that. So you have the state, which is a map with one value, hello world, and that thing is in the DOM. So this is boring demo, a bit better demo coming along. Templating. So I mentioned in JavaScript you have this JSX, and if you have that HTML and you want to describe it in React JSX, you're going to make some changes. So it's almost copy and paste, but still not quite. So you have to replace class with class name, and you have to do tab index with camel case if you want to follow the good practices. And yeah, that's it. And then you look at it, and this is still like you're inside JavaScript, and you have this text, which is supposed to be a string, but you don't have quotes because now it's inside a tag, so you don't need quotes, but it's a string. If you are to insert and express some variable here, it's now just JavaScript expression. So you can have an expression here, which is JavaScript as you know it, and now you have a string, which is not a string as you know it. So it's kind of confusing. But with the Clojure, there's this thing called Hiccup, which is a library that expresses HTML as a built-in Clojure object. So this is just, you can think of it as an array with that keyword and whatever you need it inside. And then here you actually have a proper string, because this is not a new thing on top of ClojureScript now. This is just part of it's a Clojure data structure. It doesn't need a library, but we of course need a library to render this into HTML. So I would say in terms of templating, I prefer this. I prefer that actually to HTML. And if you've done something like Haml in the Rails or something, you would love this, because this doesn't have any problems for those templating languages. Now another topic is you still have JavaScript and you still want to interact with it. And it's really easy. As I said, Clojure is meant to be a hosted language. And as in the case with Java, in the case with JavaScript as well, you have a really easy way to interoperate with your host system. So you have globals, you can just get to it through the JS namespace, and you can call any functions, like if you want to call str dot uppercase, you put the function with the dot in front of it, so you still kind of have a Clojure Lispy function first notation. And if you need a property, you add a dash to it. You can chain calls like that. With the double dot macro, it becomes really easy to transform JavaScript chain call into a ClojureScript, because you don't have to do this like backwards thing. Like on the third line, like it's a proper Clojure notation, but you can do this kind of same order as in JavaScript. And you get the chain properties the same way, because dash represents a property. And if you want to go the other way, if you want to write something in ClojureScript and use it in JavaScript, then all you have to do is export. And that works as ES6 modules. So you just import that module, and you have this myapp namespace, and you call your function, and that's it. So again, while you are going away from JavaScript, if you do this, it's really easy to interoperate. It's trivial, and if you even use other libraries, you can still inject them into your app. You actually, at the moment, you already can add any NPM packages as dependencies of your ClojureScript project, and they just load, and that's it. So another thing is asynchronous communication. So there is core async library. As I said, it's a library. It's not part of the compiler, and it works for the most part, the same way in Clojure and ClojureScript, and it's based on queues. You have a producer that puts some stuff on the queue, and you have consumers, maybe multiple consumers, who take stuff from the queue. And maybe this is the time for a demo. It's a really simple app. Basically, I wrote this app to show asynchronous communication and atoms. So we have this atom in our app, which is an integer. And let me see if this works. Yeah. So we have an atom which is an integer, and its state is in here. So it's 0 at the moment. Oh wow. It's 0 at the moment, and we have 5 threads competing for the single queue. Now, when I hit run, I have a single process that puts stuff on the queue, and it puts it 20 times. It puts just 20 messages. And it does a random amount of sleeping between calls. And this is to simulate something like a user clicking a button 20 times, and you don't know what delay is. It's random. And you have 5 threads that compete for this this queue. And after a thread takes something from the queue, it adds 1 to our value, so it increments it, and sleeps for a random amount of time as well. So this is to simulate something like when the user clicked the button, we do a network request, and we update something in the DOM, and then we wait for the request to come back, and that's random delay. So the idea here is that I'm going to put 20 things onto the queue. So the user clicked the button 20 times. And I want to see exactly 20 in the end value of that, even though random thread's gonna work on that. So once I click run, it starts like, these are the threads that are getting the value, and it's random because they sleep for random times between calls. And in the end, the current value is 20 because that was that safe atom. So I didn't care for communication, I didn't care for race conditions, I didn't care how many times actually, what threads were used. But I also had just a regular JavaScript variable, which was updated along the way with the atom. And if I look at its value now, it's 12. And if I run it again, it might be 11 or 13. So we are not having the guaranteed value there. And if you look at the code for that, it's quite simple. It's so we have one value, which is an atom. We have one value, which is not an atom. And we have this channel on which the producer puts 20 messages and then sleeps. And there are 5 consumers like that that takes an item from the queue, update the values, and then sleep. And it would be the same code, for the most part, the same code in Clojure. There are other parts of core async in Clojure that are not present in ClojureScript because, well, you don't really have access to physical threads in ClojureScript because in the browser. But this is an excellent way to work with the synchronous stuff, I think. So yeah, that was the demo. This is another demo, maybe. If we just look here. Here we have 10,000 Go blocks, 10,000 processes working at the same time, updating stuff. And the page is responsive. Like, I don't see any problems with it. And it just works. It's crazy. Okay. Another big thing is, well, yeah, now I have this JavaScript, which is created by some weird library. How am I going to debug it? Oh, there are source maps, meaning if you want to debug, you can. You just call that JS debugger function in your Clojure, and once the code reaches that, at least in Chrome, it looks like that. It gets into the debugger. I have something weird here happening because I don't have syntax highlighting, but by default in Chrome, you actually have ClojureScript syntax highlighting out of the box, and that's it. You just debug. You can get into any code, even if it's a library code, even if it's a ClojureScript code. So you don't have to think about JavaScript. It's completely obscured, even when you debug. You can call the profiler as well, because, well, at least, again, in Chrome, it's just a built-in function that you call through JavaScript global. So you can start profiling, do some code, and see the profile here. And again, if your editor does debugging, it's still the same. And for the most part, VS Code, Emacs, other editors, Sublime Text, they all have good ecosystem of plugins for both Clojure and ClojureScript. Less so for ClojureScript, to be honest, but still. Testing is there. It's a library as well, created by the same people. Simple, you define a test, you have is, then you have the whole power of Clojure behind that, so you can do any other stuff on top of it. There are fixtures. If you do web development and you need to, maybe create some environment, create a database, drop a database, and you can run that fixture for every test or for the whole suite once. You actually have a way to run fixtures with asynchronous calls. You can do something before the call and after the call. And since you have this core async stuff, you can do asynchronous tests. And this done is a function that you should call after you are done, so that this actually frees up the thread, relinquishes the thread. And when you look at, and this is the case for many parts of Clojure, is you look at the docs or the features, and sometimes, at least for the testing, it's like one page, and you look at it and you think, that's it? That's all you got? And then you ask yourself, well, what else do I need? And it's either nothing, or whatever you need, you can do by combining all those primitives. So this is the case, like they didn't invent a new thing for asynchronous testing. They just gave you universal testing and universal asynchronous stuff. So I didn't do anything about typing though, right? It's still a dynamically typed language. It's strongly typed, but it's still dynamically typed. And you can specify type suggestions, but it's not really typed language. But there's this thing called Clojure Spec, and it's a way to describe data and then validate on top of that description, or generate data on top of that description. So here, for example, we're checking if something conforms to any predicate, and we have an even predicate, and we confirm that 1000 is actually is even, and that ABC is a valid string. We can define specs. So here I'm saying that work weekdays is a spec that's a set of those 5 days. And if I check conforming Saturday, it should actually be valid. But Saturday is not a work weekday, so it's going to say false. Of course, you can combine them. So that's the example from docs. You have big even, which is something that conforms to integer predicate, even predicate, and this function. This is just an anonymous function that says the argument is larger than 1000. And now you say, well, that foo keyword, it's false because it's not integer. This 10 is false because it's not more than 1000. And 10,000 is true because it conforms to all of them. And if you want to see what's wrong with it, what's wrong with 5, you do explain. And it actually shows you, even if you have nested specs, it will show you that it doesn't conform to that even part. So it's integer yes, even no. And you can imagine this being used in validating complex JSON structures. You get JSON from the pipe, you want to validate what's wrong with it, and where exactly is, like in JavaScript, undefined is undefined. You want to see where exactly is the problem. If you have a specification for that, you convert that JSON into ClojureScript, basically Clojure data structure, which is a built-in function, by the way, and then you check it. And the cool part is this is something that's familiar to people doing Haskell and quick check and property-based testing, is that once you have a specification, you can generate data on that specification. You can generate tests. You can generate, stuff to put into your database that conforms to some data. And there's a generator, and you can get some sample data based on any spec you have, just like that. So another thing that people care about that much is community. And community of Clojure is, of course, small, but for at least half of you, that's a familiar experience. It's not like JavaScript. It's not like Java. But the community is nice. People are nice. There's no, people say there's elitism in Lisp community, in Clojure community, in Haskell community, whatever. Some people maybe are not that nice, but questions are answered. You go to Stack Overflow, bunch of questions, one answer, canonical answer. No much discussing. This is how you do it. That's easy. Unlike JavaScript, where you have 10 different ways to do it. There are still quite a lot of conferences. One coming up in Belgium, I think, and come to Finland. This is weird because there are not that many developers in Finland, not that many people in Finland, but statistically, there are a lot of Clojure developers in Finland for some reason, and one of the biggest conferences in Europe is coming up this fall in Helsinki, I think. So if you like that, if you want to get into it, there are some resources. Rich Hickey is the guy who created Clojure, and he still works on Clojure, and you can see a lot of motivation behind the language, behind the design and decisions from his talks. And if you haven't seen, I highly recommend at least watching that one called Simple Made Easy. It's the core philosophy of Clojure, and I would say good programming in general. There's this free book, Clojure for the Brave. You can also buy a physical copy, of course. And there's this Luminous framework. And framework because it's not really a framework, it's a curated collection of libraries, basically, for front-end and back-end web development. And if you get into ClojureScript specifically, there's this website, ClojureScript.io, which is an online environment. If you don't want to mess with those environment setting up stuff, then you can still try ClojureScript, play with the DOM, play with the libraries in the browser. And if you just read Reagent intro docs and this Reframe, another library docs, they are really good, especially Reframe. It reads like a story. So there are still things that skeptics and you might think there are reasons not to do it. So some people say it adds complexity because now you have this whole new thing. But the fact is, if you want to write modern JavaScript, you already add complexity, because if you want to write modern JavaScript, you're not writing native JavaScript. You're still compiling it into native JavaScript because browsers don't support fully ES6 and stuff like that, and you need a transpiler from JavaScript to JavaScript. So you still have a lot of complexity even if you stick to JavaScript today. Performance issues, as I said, for the most part, it's as fast and sometimes faster than at least React. The real pain here is that it's still Java, like inside. So startup time is quite slow, but once you're running, it's okay. People care about popularity. There are not too many companies using Clojure professionally, but some are, and companies like Walmart even uses them. And the last thing is parents. Lisp, lots of parents. People are scared, and for that, I'll give you another comic of mine. Just two workers on a smoke break discussing that Lisp is ugly with those endless parents. He says, yeah, of course, for sure. Let's get back to work and get back to JavaScript. All right. Thank you. Any questions?
So, unfortunately, I don't think we have that much time for questions, so maybe just one.
Well, thanks for the presentation. I mean, it was my first exposure to Clojure and ClojureScript. So my question is about reusing JavaScript libraries. So if I, for example, want to use React component libraries from Clojure, will I be able to do that without someone first writing a wrapper?
Yes.
For that?
Yes. Once you have React in your runtime, you can reuse components. Will be a bit finicky, but you don't need someone to write a real wrapper or rewrite your component. All right, come talk to me afterwards.
Yes, thank you very much.